This video is all about valuing and pricing interest rate swaps. Valuing is all about computing the dollar value of it, and we know from earlier discussions that the value of a swap is equal to the value of a fixed bond plus the value of a floating bond, floating rate note. Okay, whether there's a plus sign in front of this or a minus sign depends if you're long or short. So if you're going to receive fixed, there's a positive sign here because you're going to receive the fixed rate, and then you're going to be short, there'll be a negative sign here in front of the floating. So you're going to be long a fixed rate bond and short a floating. And if it's a pay fixed, receive floating, a pay fixed would be you'd be short a fixed, and if you received the floating, you'd be long the floating rate instrument. So the point is the value of a bond is the value of a fixed rate bond plus the value of a floating rate bond, where the pluses or minuses depending on whether you're long or short. And then the last half of this video will be about pricing swaps, where you determine the interest rate, the swap's fixed rate, K. In this video, I will value an interest rate swap that's in between reset dates, and the reason why I'm valuing a swap between reset dates is because as you know, if you value a swap at a reset date, the value of the swap, and I'm talking in dollars now, not a percent, the value in dollars is 0. In between reset dates, just like with a floating, you're going to see that the swap will have a value that's different than 0, and really at any point after inception, you're going to find that a swap, a plain vanilla swap, will have a market value that's different than 0. And then at the end of this video, I will show you how to price a swap. And when I say price a swap, that means determine the fixed rate that's associated with it, and that's labeled K as the variable K. Okay, so now what we have, as you can see here, I have the background for the value of a swap. So here's our timeline here. Today is time 0. This swap was created 150 days ago, and the next cash flow is 30 days, and the next cash flow is 182 days later at after this point, and that from today is 212 days from now. Add another 183 days, another 6 months, and the last cash flow is 395 days from now. Okay. What's also given here are the spots. The spot rate is 2%. Okay, and the spot rate for this time frame is 2.5%, and then the next spot rate is 3%. Now, from this, you can calculate the discount bond prices, just like we did with the forward rate note. I'm not going to rehash or reiterate that, but you basically the present value of $1 today is $1 basically. So that's where the 1 comes from, and then this is $1 discounted at 2% for 30 days is really worth 99.83 cents, and so on. And then the forward rates that we compute from these discount prices are 2% for the first forward rate, 2.58 for the next forward rate, and so on. So that's the information that's given from the yield curve. So I make it kind of easy in this problem because this problem I'm focusing on valuing a swap. So I've given you this information here. Now, the additional information you need to know to value this swap is the notional value of the swap that I'm going to work with is 10 million. It's a received fixed swap, so you're going to receive a fixed payment. In this case, it's going to be 2.5% of the notional value. Now, the convention for the fixed side is we're going to assume 30 days per month out of a 360-day year for the fixed side. and we're going to assume actual divided by 360 for the floating side. Now, it seems a little strange that swaps were done this way, but remember the fixed and floating markets in the world before swaps pretty much developed separately, and they had different conventions. And now you have come along with a swap, which have only been around for about 30 years. Swaps combined the money market side, the floating side, with the fixed side, and so they've they have adopted, people who've built these swaps have adopted both components, which is sometimes called the money market side of things, which is the floating, and the fixed convention. So we just have to get used to it. It's a little bit of extra math, but not hard math. So let me calculate and value this swap. So what we're going to do is I am just going to take the difference between the forward rate adjusted for time and the swap fixed rate adjusted for time and discount it back. So this is what I'm going to do. So here's the discount rate. I just right here copying it down. Now we receive fixed, which is 0.025, receive fixed. Now I need to adjust it for the convention, and we're looking at 6 months worth of time, so this is 180 over 360. So this is what I'm going to receive adjusted for time. Now what I'm going to pay is the floating, and that's at this point this forward rate, 0.02 times the actual number of days divided by 360. Now the actual number of days here is the sum of 30 and the 1/5. It should be 152. Yeah, it's 152 there. So now it's 182 divided by 360. Okay, this equals 0.0025. And so again, I'm working on everything as a notional value of $1, and then when I get done, I'll multiply everything by the $10 million. Okay, so now let's do the next two cash flows. Now here's my discount rate. Here's the 2.5%. Now here's the floating side coming down here. 182 days in that time period, as you can pick up here, 182. And then the last cash flow, the discount rate. Here's the floater, 183 days between here and here. Add this up, multiply by 10 million, the notional value, and we get, sorry about that, we get a value for this swap as minus $32,900 is the value of this swap. It's 32,900. So all I did was, look, I took the difference between the interest rates, the fixed rate and the floating rate, adjusted for time, and I discounted it back. Because remember, swaps they swap interest rates and payments, and that's what I'm doing here. Adjusting for time value of money, and then adjust for the notional value all at the end. Now, another thing, so that's basically a swap. You should also realize that you can value the swap as the sum of a fixed and a floating. Just draw a timeline here. The fixed side, we're going to get 2.5, 2.5, and 2.5 each period. We need to discount each one back, 0.989983, This comes out to be now, what this is telling you here is all I did was I discounted back the interest payments for a fixed rate bond. I'm saying, look, this bond pays 2.5%, right? Oop, be careful here. I need to put in it's 2.5% adjusted for 180 over 360. So just multiply this by 1/2. 180 over 360, because it's on a 6-month basis. So multiply by 180 over 360. So it's really, you're getting 1.25%, 1.25%, and 1.25% each of these time periods. And discounting that back, add that up, and don't forget the present value of $1, right? The present value of $1, because technically this last payment I'm going to get my principal back if we're just looking at a fixed rate bond. And so the present value of that is nothing but this number, 96 cents, a little more than 96 cents. So the value of a $1 notional value, notional bond, a $1 notional fixed rate bond, is worth a little over $1.50. Basically, it's $1 plus and 1/2 cent is the value of the fixed side. Now we can value the floating. Okay. Let me value the floating. And I'm going to discount those floating rate payments, those expected floating rate payments. So that's 2% was the first floating rate payment times the 182 divided by 360. And then the next floater was 2.58% times 182 divided by 360. And the last cash flow is this. Now take these numbers, discount them back with the 0.9983, and this comes out to be getting these off on the table that I gave you. Add this up, and the present value of the expected floating rate coupons, the present value of expected floating rate coupons is about 4 cents. Don't forget to add the present value of $1 that's received here, because you buy a floater, you're going to get the principal back at the end. And the present value of that floater is that last discount rate. And so the value of the floater is worth almost $1.01, okay, per $1 notional value. Now, this was the floater side, the value of the floater, the value of the fixed. This was the fixed. And so we take the value of the fixed, subtract out the value of the floater that I just computed, and here is the value of the swap per dollar. Okay, notional value times the 10 million. And the value of this swap, this guy's negative. The value of the swap is $32,900 in the red, in the negative. And that's how you value a swap. Now what we want to do next is we want to price the swap. In other words, determine a swap's fixed rate. Now, when you determine a swap fixed rate, you're determining it at inception. And basically what it comes down to is K is the swap fixed rate, and that is nothing but an average of the floating rate payments. The logic behind determining the swap's fixed rate is that the value of the floater should equal the value of the fixed rate bond. Okay, because remember, a swap is composed of a floater and a fixed rate bond, and so when we set those two equal and we determine K, that is the swap's fixed rate. So let me show you mathematically. The value on any reset date and at inception, which is where we're looking at here, the inception of the swap, the value of a floater is $1. Okay? Now we're going to set the value of that floater, which is $1, equal to the value of the fixed rate bond. Okay? So it's a floating rate bond, fixed rate bonds on here. This side. Oops, it's a 1. Now, so here is the fixed side of the swap, and that is the swap fixed rate K, which is what we're going to solve for, adjusted for the time period, which is usually 6 months, or approximately 6 months, and that'll be a function of the actual day count. And then here's the discount rates associated with that. So we're discounting this rate adjusted for time with this discount rate. And we're adding those up, and so right here in the big brackets, in this big bracketed area, is the value of all the fixed interest payments only. Don't forget, at maturity you get $1 back, but you have to discount it to today's money, and so you discounted it based on that zero discount bond that starts today and uses the spot rate that goes to period end. So this being generic as to the length of this swap end periods. So to reiterate, we're indifferent between investing in a floating versus investing in a fixed rate bond that pays K. So now all we need to do is solve for K. We solve for K by first bringing K outside of this big bracket. You see K is here, it's here, it's here, it's a constant. And so if we bring K outside of this bracket, we get K outside. Okay, and so now all we do is we subtract this component from both sides. Subtract it from here so it crosses out, subtract it from here. Okay, and then what we have is this equals K to what's inside the brackets. Now divide both sides by what's inside the brackets, and what we get is this. Running out of space here. Okay, this whole thing, and again, this is only for a three period swap here, but it goes on obviously if you go out to N, and this is what K equals. Okay, so this is the formula that's in the textbook, and so really it's 1 minus the very last swap rate, or the swap discount rate, or this discount bond price right here, this 0.9681, and then divide it by the sum of all the other discount bond prices adjusted for the time period that's involved. And usually this is about 1/2 in these cases. You know, it's 182 over 360, 183 over 360 approximately, so it's about 1/2. So it's the sum of the discount prices adjusted for time. Intuitively, looking at this, you don't have a lot of intuition here. You look at this, and you look at this example, this formula that's in the textbook. It looks kind of dense, but again, if you realize that all you're doing is you're setting the value of the floater, and this floater price reflects all those floating rates. This side reflects the constant K, fixed rate, that we're trying to solve for. And when you equate it, you come up with, and you solve it, you get K. Not too intuitive in this form, but it works. Using the problem at hand, we can solve for the swap's fixed rate. So coming off the tables that we had before, okay, using these information from this table, I'm going to take K equals 1 minus the discount bond price for the last period, 0.9681, and divide it by the payments times the day count, or the discount, the day count right here, times the zero discount price. And so the zero discount price is coming right off of the discount bond price schedule here. So, as you can see, the swap's fixed rate for this, if we were to value the swap at this point, now remember, the swap that we dealt with here, and I calculated the value of the swap, this is a swap that already existed for 152 days, and the swap's fixed rate was set and determined at 2.5%. Okay, it was determined 152 days ago. Now I'm saying, under the same situation, if we were to start up a swap, brand new swap, based on these spot rates, what would be the swap's fixed rate? The swap's fixed rate is nothing but an average of the forward rates. And so you see the 2.97% falls in right about here as being an average. And you got to remember, the average is adjusted for time, so this 2% only is a function of 30 days. And this 2.5% is a function of 182 days, and this is a function of 183 days. So it's time-weighted average, and it comes out to be 2.97. So as I said before, the swap fixed rate is nothing but a weighted average of the forward interest rates that you're going to receive, that you expect to receive.